Unit 9, Part 1, Lesson B. We're going to talk about solving quadratics. After this lesson, you will be able to solve quadratic equations, classify a number as rational or irrational. So in order to be able to talk about solving quadratics, we actually need to revisit our list of perfect squares. Now, squaring, as you can remember, means timesing a number by itself. So, for example, if I have 1 squared, that's really 1 times 1, which will give us 1. Likewise, 2 times 2 is going to give us 4. 3 times 3 is going to give us 9. Go ahead and pause the video now as you finish filling out this list. Press play to check yourself. And there you can see our finalized list. You have your perfect squares: 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, and 225. You're going to have a calculator for most everything you do, but sometimes it can actually help you to be a better mathematician to have your perfect squares memorized. So that's something we're going to be working on throughout this unit. Now, what values of x could I have if x squared equals 4? Well, in order to say x squared equals 4, I'm going to look at my list of perfect squares. I know that I have 4 when I look at 2. So if I go ahead and I go back to where it says x squared equals 4, I know 2 times 2 equals 4. 2 squared equals 4. So x could equal 2. However, there's this other side we have to remember, that in order to get positive 4, I also could have had negative 2 times negative 2. That would have also given me positive 4, which means that x also could have equaled negative 2. So in today's lesson, we really got to keep in mind that when I have x squared equal to something, I could have x be a positive value as well as a negative value. Now we're going to remind ourselves of the inverse. Remember, inverse is just a fancy way of saying opposite. What operation is opposite? What operation would undo multiplication? Hopefully we're thinking division. Addition is the inverse. Again, that means opposite. Addition is the inverse of subtraction. Now this last one might take a little bit more thinking. Squaring, so that would be, for example, x squared. Squaring is the inverse, again we're talking opposite, of, well, it's got the word square in it, it is square rooting. So that would be, for example, the square root of x. So if I had x squared equals 4, I could go ahead and take the square root, which would cancel my squares, but if I do it to one side, I must do it to the other side. That will give me the answer of x equals, well, as we know from earlier, it could be positive 2, and it also could be negative 2. So another way we could write our answer is x equals the positive and negative of 2. And that again comes from the fact that it could have been positive 2 that I squared, it could have been negative 2 that I squared. So when you take the square root, you always have a positive and a negative answer. Now what you see here is a list of perfect square roots. It actually is very related to our list of perfect squares. The only difference this time is we have our radical. Radical. That's also what we call a square root. Now, in order to get this positive and negative 1, I must have taken a square root of 1. In order to get this positive or negative 2, I must have taken the square root of 4. Go ahead and continue the entire list. Pause the video as you work. Press play to check your answer. And there you have it, is your list of perfect square roots. The big takeaway you should have is the fact that when you take the square root, you get both the positive and the negative of the answer. So don't forget, you have both the positive and the negative when you take the square root. Now, what we also need to understand, since we're using square roots, is this concept of classifying numbers. All numbers are either going to be rational or irrational. Over here on the blue side, rational numbers are going to be ones that make sense. And that's because they either end or they have a pattern. So they're a number that makes sense. They either end or have a pattern. Examples of that are going to be like 2. 2 is a number that ends. 1/2, again, that is a number that ends. 0.02, a decimal, but it ends. 2.2, again, a decimal, but it ends. Now, 0.222 goes on forever. I also could write that as 0.2 with a repeating bar over it. However, it's still rational because it has a pattern. I know the next number is going to be 2. So that's how I could say that one makes sense, because it is a pattern. Now what you see here is the square root of 4, which is going to give us the value of 2, or negative 2. Don't forget, there's 2 answers there. Now down here, I want you to see perfect square roots are considered rational. They make sense. Now, in order for rational to exist, we have to have the opposite, which is irrational. Irrational numbers don't make sense. They are numbers that never end. They're also numbers that do not have a pattern. So we're looking for never-ending numbers, and we're looking for no pattern. Some examples are the most famous one, which is pi. Pi is famous because it goes on forever, and it never has a pattern. So 3.14159, I don't know what's coming next, so it doesn't make sense because there's no pattern. Now what you notice here is we also have the square root of 3. The square root of 3 would be considered a non-perfect square root. I don't know what the square root of 3 is. And if I typed it into my calculator, I would have to write 3, hit the square root button, and it is going to give me I'm going to get 1.73205088 ... I get a never-ending, no pattern number, which is why non-perfect square roots are going to be irrational. So as we go through solving our quadratic equations, we are going to get square root answers. We are also going to be classifying them as either rational because they are perfect square roots, or irrational because they are non-perfect square roots. Here we go. Example 1. What I notice is that it has a square next to my x. In order to get rid of squaring, I need to do the inverse, which is square rooting. A square root and a square are going to cancel, and what drops down was what was underneath the radical. In order for me to do this properly in an equation, what I do to one side, I also need to do to the other side. So this equals the square root of 225. We should be recognizing that as a perfect square root. So x is actually going to equal the positive and negative of 15. Now, in order to classify this, I need to ask myself, was this a perfect square or was this a non-perfect square? This was a perfect square, so it is rational because it is a perfect square. And you might not have recognized 225 as a perfect square, but that's exactly why we're going to work on our memorizing those so we're able to see it much quicker. Go ahead and pause the video now as you try example 2. Press play to go over your answer. There we have taking the square root on both sides because it's x squared. We're going to get x equals the positive and negative of 8. This is going to be rational because it's a perfect square. Pause the video now as you try example 3. Press play to go over your answer. Make sure you're doing your best. I believe in you. So we know to take the square root on both sides. My square root and square are going to cancel, which gives me x equals the square root of 37. Now, I don't know what the square root of 37 is, so here's how I'm going to write my answer. X equals the positive and negative square root of 37. And of course, that is going to be irrational because it is a non-perfect square root. So if we were to type that into our calculator, we would get a never-ending decimal that doesn't repeat. That's the reason why it's considered irrational. Pause the video now as you try example 4. Press play to go over your answer. There we have it. X equals positive and negative square root of 17. It is considered irrational because it is a non-perfect square root. What we notice happens at example 5. I have something else besides my x squared. In this case, we're talking about this 3. I cannot take the square root unless everything else is moved away. I need to isolate my x squared term. So in order to do that, I need to get rid of my 3, which is multiplying. The inverse is division. That is going to cancel on the side to give me x squared equals 75 divided by 3 is 25. And now I have the exact same situation where x squared equals a number, so I take the square root, which cancels. I get x equals positive and negative 5. This is considered rational because it is a perfect square. So right there we have exactly the same process, but I had to move away anything that was touching the x squared first. Go ahead, try example 6. Press play to go over your answer. Make sure you're trying your best. So the first thing we do is divide by 2. That is going to give us x squared equals, go ahead and divide it, to get 196. We know to get rid of the square root, we need, or the square, pardon me, the square root, which cancels, giving us x equals the square root of 196, which is positive and negative 14. It's considered rational because it is a perfect square. All right. Go ahead and pause the video now. Oh, actually, let's talk about this one in example 7. Notice we do still have our 3 out in front of the x squared. However, I also have a term that's being added or subtracted. I know in my solving that I always move that constant term first by doing the inverse. In this case, it is addition. That is going to drop down my 3x squared, which equals 363. Now I have a problem, just like the previous one, where I need to get rid of my coefficient by dividing. That gives me x squared equals 121. My last step is to get rid of my square by square rooting. I do it to both sides. X equals the square root of 121, which I know means it is positive and negative 11. It is rational because it is a perfect square. Go ahead and pause the video now as you try example 8. Press play to go over your answer. Do your best. I believe in you. So we subtract 10 on both sides to give us negative 4x squared equals, remember we're doing money math, I owe you $314. I borrow 10 more, so I owe you $324. I then divide both sides by a negative 4, and I end up with x squared equals positive 324 divided by 4 is 81. Our last step is to square root both sides to get x equals the positive and negative 9, which is considered rational because it is a perfect square. Go ahead and pause the video now as you try example 9. Press play to go over your answer. Do your best. We add the constant 6 to both sides, which gives us negative 2x squared equals negative 28. We divide both sides by negative 2 to get x squared equals positive 14. We square root both sides to get x equals both the positive and the negative square root of 14. That is going to be considered irrational because it would give us a never-ending decimal when you input a non-perfect square root. All right, here comes the last one. I know this is a little tricky, but remember your inverse operations. Pause the video now to try on your own. Press play to go over your answer. We're almost done. You're doing great. We subtract 5 on both sides. Drop down your x squared divided by 3, which now equals 48. Now, because 3 is divided, I use my inverse operation, which is multiplication. I do it on both sides to get x squared equals 144. Square root both sides, x equals positive and negative 12. This is considered rational because it is a perfect square. All right. Absolutely great job, guys. Go ahead, begin working on whatever your teacher wants you to work on, and have a wonderful day.